I'm the Education Director with NOFA Mass, Northeast Organic Farming Association, Massachusetts chapter, and I am also our Soil Carbon Program Coordinator and a Soil Health Consultant. And I am out here today at Caro Community Farm in Woodbridge, Connecticut. And what we're doing today is demonstrating a soil health assessment, or soil carbon proxy test, as we call it at NOFA. So before you begin to conduct your full tests, if you're a technician doing this test for a farmer, you want to conduct an interview with the farmer to get history of their farming practices, such as tillage, mulching, cover cropping, and the last few crops that were in this field. Things like what fertilizers they're using if they're applying compost. And you want to record things like the weather and the temperature, obviously the date, because you want to conduct this test at the same time every year, and draw your map to where the test is taking place. At that point, you can move on to begin your tests. So there's two ways to use these tests if you're doing your own soil health assessment for your farm. One is to do a comparison test, so that would be to test two different fields or two different areas in your field or multiple areas in your field. In that case, you'd want to choose different locations within your field that you know have different soil conditions, such as higher, lower, rockier, less rocky, wetter, not as wet, and compare those. If you're going to be using this method for tracking change over time to look at your management practice and how that's affecting your soil health from year to year, you would just choose one location in your field that's representative of your field and look at that same exact spot every year, because as we know, soil conditions are variable, so you want to choose one spot and compare that over time. The materials for doing this test are really quite simple. It's just a long surveyor's tape. I had a 150-foot tape. I switched to a 300-foot tape for different farms, because what you really want to be able to do is measure from a permanent landmark. So on this farm, what I've done is looked to the corner, the absolute corner of the farm. I'm going to draw a map with cardinal directions, and I've counted from that corner 8 posts. So when I record the location for this spot, it'll be count 8 posts up from the southwest corner, and then measure 115 feet and 6 inches to the center of the test location at 185 degrees on my cell phone compass. So that's basically the directions I'll record for myself. There's also some water mains nearby, just simple metal poles that indicate where the water sources are. So if you wanted to get really fancy, you could use your compass and actually also in your surveyor's tape and triangulate from those spots if you wanted to get really precise. You can also use GPS apps on your phone, but they're generally not as precise as these directions you can make for yourself. The materials that I've used for this, like I mentioned, a 300-foot surveyor's tape. This is just simple PVC pipe cut to a specific length and joined with a simple coupler kit that you can get at Home Depot or your local hardware store. And the goal is to make a 30-inch diameter hoop. This just allows you to better estimate percentages of cover. And the hoop is just to sort of help you focus on a specific area of a contained amount of space. And what the goal is to estimate the percentage of living cover, residue, or dead cover, and bare soil in the hoop. And the test is conducted from a standing position looking down for estimates. So we're not getting down here and like moving the plants around to kind of like look at the bare soil. This is just a simple surface observation. So from my perspective, standing here, what I'm seeing is about 5% bare soil. Very little what I would call residue, less than 2%, maybe closer to 1% of residue, just kind of dead plants. And mostly living plants, which is really good. There's actually companies now that work for farmers by conducting satellite imagery of their farms to estimate the number of days in living cover that farm has. We're talking big farms out in the Midwest, big row crop farms. And you can actually get a pretty good estimate of the amount of carbon you're sequestering on your farm from your days in living cover, because the carbon that's moving into the soil is mostly moving into the soil through the process of photosynthesis, right, of CO2 being converted into carbohydrates, which are carbon-rich sugar compounds. So what we're seeing here is mostly living cover, which is really good. So we have about 95% living cover. A good trick for estimating percentage of different components in a 30-inch hoop is that a hand fully outspread is about 6% of a 30-inch diameter hoop. My hands are pretty small, so I usually estimate more like 5% for my hand. If you don't spread your fingers, that's closer to 4%. The side of your fist, so like thumb side down, which is a little hard to do, but like that, is supposed to be about 1%, and a thumbprint is 1/3%. So hopefully that's helpful if you need visual estimating tools. The other thing you want to record in your data sheets, which we will provide a link to be able to access the whole manual and data sheets for these tests, is the species richness or species diversity inside the hoop. So looking here, what I'm seeing are chickweed, vetch. This is some kind of an aster. It looks like something in the daisy family. Oh, there's also a wild onion. So I would say that this is primarily vetch, probably about 90% vetch if we're thinking about it from a canopy dominance perspective, with maybe 7% chickweed visible, and the remaining 3% is a mix of these asters and wild onion. The importance of the species diversity really has to do with the fact that different soil microbes partner with different plant families. So part of increasing soil life and increasing soil carbon is about increasing the life in the soil, and you can support more life in the soil if you have a more biodiverse soil ecosystem. An ecosystem that is dominated by one plant is only going to support a more limited set of soil microbes. So that's part of why species richness is important, and why cover crop cocktails are a really, really good strategy for increasing soil health. And at this point we can say that the soil temperature is 59 degrees. So the next thing we're going to do is remove the hoop and dig a hole. We're going to do a number of things with this hole, but it's important that we want to dig a cubic foot of the soil and displace it into a bin or a tarp. I used to carry a tarp around, but I've just moved on to kind of really preferring having a bin. The reason for that is we're going to be looking for earthworms in that bin, and I just find it a little easier as I'm getting to the end of my cubic foot of soil to sort through it from a bin. In this particular hole, the majority of the roots seem to terminate at about 5 inches, which is really good for springtime. And we have at least one root that goes all the way to 12 inches, and I'm seeing a couple other ones that are at about 10 or 11 inches, so that's really good. So it doesn't appear that any of the roots are sort of hitting compaction points. None of the roots are abruptly turning sideways. None of them appear to be balling up. So we have good root behavior. The next thing we're looking for are biopores, or sort of channels in the roots left by earthworms and roots. And at this point we just count what we see in terms of biopores in the hole walls. I'm seeing about 3 visible biopores on average per wall. So about 12 in the hole. Double checking that. Fewer on this wall, so maybe I think we'll say 10. Yeah. The other thing we're looking for in the hole is the depth of topsoil. So what we're looking for is a color change. On a farm that's tilled regularly, I usually see a pretty bright line of dark colored topsoil, light colored subsoil, usually at around 9 inches. Typically, and that's, you know, the depth of the plowing on that farm. And they develop plow pans, so you just see a really sharp distinction. On a farm like Caro farm, that has been using no-till practices, you often see a much fuzzier gradation, a marbled appearance, and we clearly see that on this site. The color change from the dark topsoil to the lighter subsoil is much more gradual, and like I said, marbled is the best way to describe it. So you see here on this slice with the painter's trowel, which is a really important tool for your soil health assessment. Painter's trowels are invaluable. We have this nice dark topsoil, but it doesn't transition abruptly to the lighter colored subsoil, and that to me is a sign that the merging of the subsoil and topsoil is happening a lot through root and worm and other biological activity, and not through just plowing and turning over one layer of the soil. Another aspect of the soil system that we're looking at when we do the digging a hole test is root sheathing. So this is basically the strength of the relationship between the plants that are growing on site and the soil community. You can see here that these roots are very tightly sheathed in soil, so that you can't see very much of the primary root through the soil clinging to it. Grass is one of the better, I just went and grabbed this clump of grass because grass is one of the better plant families to test this on. But it's a sign that there's really strong relationship between the soil biology and the plant. So there's a lot of exchange happening in the form of carbohydrates and other components of the root exudate that is causing the ecology of the rhizosphere to have a strong connection with the plant. Other plant families, well, that relationship is going to look a little different. Like typically, as most growers know, onions their roots don't tend to sheath as much. Here we have some chickweed that you can see a lot of the root through it, but at the same time there's a lot of aggregation growing off of these roots. But generally, if you have a grass present, I like to stick with a grass to test the root sheathing. I just go find one near the test location if there's not one right in the hoop. But this is really, really nice sheathing here. If you saw just kind of, if it was more similar to the onion root and you could see a lot of the root through the soil, that's less good sheathing. That's not as good sheathing. So you're really looking for that really nice thick coating of soil on the root. Next test is aggregation, and this part's probably the trickiest part of the whole set of protocols. What we're doing is classifying the aggregates that we find in the soil, and we want to be using the NRCS classifications for aggregates, so you can actually find a full description on soil aggregation in a field book called the Field Book for Describing and Sampling Soils, which is put out by NRCS. You can find that on their website. We have sort of a simplified version of their categories in the protocols just to make it a little easier for you, but if you wanted the expanded version of it, you can use their original resource. But what you do is you create a slice of your soil and you place it in front of you to look at. And what we do in our protocols is we classify the aggregates in the top 4 inches, 4 to 8, and 8 to 12. And so I've actually compressed them just a little bit here, just to make it a little easier to see. So we want to be looking at the aggregation at 3 different levels, 0 to 4, 4 to 8, and 8 to 12. So this is 0 to 4. You can see here that there's a lot of really nice aggregation. I would call this granular aggregation. And this is fine to medium size. And for a full description of those distinctions and those different categories, you can look at our manual, which we're providing a link to with this video. But these are granular aggregates because they're relatively circular, and the size classification is fine to medium, which has to do with the number of millimeters of diameter the little aggregates have. But the other aspect is prevalence. So prevalence is the relative preponderance of the aggregates compared to either solid compacted soil or loose playground sand, kind of like falls through your fingers, not aggregated soil or unaggregated soil. So this is, I would call this a strong prevalence. We usually grade weak, moderate, or strong, and this is definitely strong because I'm seeing basically no unaggregated soil here. Oh, here's a nice macro aggregate. Oof, that's beautiful. It's got some vetch nodules in there, rhizobacteria in there. But yeah, you can see that as you break apart the macro aggregate, it just breaks apart into smaller aggregates. So that's a strong prevalence. For the middle profile, 4 to 8 inches, we have, you can see that we have actually more what looks like coarse, blocky aggregates. Granular aggregates are considered higher soil health. These are larger, but they're not as separately aggregated, and they are, as you break them apart, they're kind of not falling apart into this cottage cheese kind of appearance, but they're a little bit more chunky. Still I would call these aggregates and not kind of clods because they have good porosity, and they're nice and dark in color, and there's roots moving through them, and there's little pores in them. But as we move deeper and we start to get into some of the subsoil, if you were to find just chunks of soil that are hard, like rocks, and are very smooth on the edges, don't have good porosity, you're starting to get into what is just massive soil or just clods of soil that aren't really aggregated. But this is still kind of in the realm of what we would call aggregated soil. But there's no real bright line between those categories of clod and aggregate. It's a little bit subjective. I've had many conversations with my state NRCS soil scientists to sort of help try to define these things, and really it's just a matter of exploring, and it's a little bit subjective, but this is still really nicely, has a lot of surface area, and it's in the realm of cloddy because there's less roots going through it, the color is lighter, and it's blocky. But as we head down into the soil profile, we're looking at a weaker aggregation, blockier. Up here we have granular and strong prevalence, and as we go down, we're finding weaker prevalence and blockier structure. So the next thing we're going to do is actually count the earthworms in that cubic foot of soil that we displaced from the hole when we were first digging our hole. That's why we're putting it in a bin. Generally, the beginning, there's not going to be much earthworms in the top because they've all gone down to the bottom, so that's usually where all the action is, but we're just going to sift through it. First thing to do is take your little cup that you're going to be putting your earthworms in and put a little moist soil in it so that they have habitat and they don't dry out. If it's a really hot, dry day, I usually put a little water in the cup too so that they're comfortable while I'm counting them. So at this point, as I am searching for worms, I am filling the hole back in that we dug handful by handful. It's worth mentioning here that if you're doing a technician level protocol of the carbon proxy test, you actually want to do your bulk density test before this point because you need that hole. But this is a demonstration of the more farmer gardener friendly protocol, so we're not going to do bulk density on this video today. We found 6 earthworms in this soil. So this is one of the most seasonally variable tests that we do. It's really important to really do this test the same time every year because your earthworm count in your cubic foot of soil is going to vary a lot by time of year, temperature, moisture conditions, but time of year being one of the things you can control. So taking the test the same time every year, you should expect to see fewer earthworms in the summertime than you would in the spring or the late fall. The infiltration test is a test that measures how quickly water infiltrates into the soil. different aspects of the soil structure, how well aggregated it is, how good the sort of capillary action is from root channels and earthworm channels into the soil. All of those things impact it, whether there's surface crusting. So it's a really good measure of soil health. Typically we see anywhere from 4.5 seconds to up to 45 minutes for this test. It's really wide ranging. We'd like to see things under 20 seconds, ideally. Under 10 seconds is really good. So the way to do this test is you bang in a cylinder. This is just a basic sewer, 6-inch sewer pipe, plastic sewer pipe that's been sharpened, cut to 6 inches and sharpened on one end. Use a piece of scrap lumber to pound it in with a mallet. And then we use just basic cling wrap covering the surface to allow us to pour the water in and then start the infiltration all at once. For a 6-inch cylinder, it's 444 milliliters of water that we use, so I just carry a jar that has that amount marked out on it, and I pour it into that container on site and then into the cylinder with the plastic on it. Pull the plastic off and start my cell phone stopwatch at the same time. Any stopwatch will do. Since I use a phone for so many aspects of these tests, it's just the easiest thing. And so this test was, we got 17 seconds for infiltration, which is a good reading. The Penetrometer Test tells us the depth to compaction in a soil. Most roots for standard crop plants can't penetrate soils that have pressures of 300 pounds per square inch or more of pressure required to penetrate the soil. So for this simple tool, this is an Agritronics penetrometer, has 2 dials on it, one for a small tip and one for a larger tip, which you just decide to use based on how firm the soil is on site. And the dial tells you basically under 200, between 200 and 300 psi, and then over 300 psi. The penetrometer has 3-inch marker lines along the shaft, which you use to sort of tell where you are. It's a little bit of it's kind of like driving, learning to use this, because you have to scan a lot of different things at once. But basically the way to use it is you place it on the soil surface. You want to make sure you can see those lines, and you're applying a steady pressure, and you're looking at the line and the dial and the line and the dial and the line of the dial at the same time, basically going back and forth. So I'm getting, as I was passing the 3-inch mark there, I was at about 100 pounds per square inch. So you continue applying steady pressure and you're looking at the dial. I'm at 200 now as I go past 6 inches, and then about 210 as I go past 9. As we're hitting 12, I'm at about 250, and I'm encountering a little bit of resistance from gravel, it feels like. As we go to 15, I'm up at 300 now, and I can't push the penetrometer any farther down. So I will take 3 readings for the growers. I usually throw out a reading where I hit a rock pretty early on in the process. If a soil tends to have a lot of rocks all at the same level, then we just have to live with that as our reading. But I'll give them the average of those 3 readings, which is generally a better indicator than any one individual reading, since soil is variable. And it's important for the grower to know where, if they have a plow pan, if there's like a zone of the soil where the PSI is 300 or over, because that's the pressure at which roots can't penetrate. And then I also like to flag readings of 250 and over, because such a small percentage of crop roots can penetrate it at 250. So the Slake Test is basically a test of how well the soil holds up to water infiltration, or sort of like water submersion. the amount of sort of biological glues in the soil holding the soil particles together create kind of water resistance for the soil structure. So what we're going to do is take these two samples. You want about a golf ball size of each. They should be about the same amount. And we're going to place them in these ball jars of water that have little baskets made out of hardware cloth in them. And we're just going to place them in the baskets and see what happens. So we're looking at really two factors here. We're looking at how much of the clod of soil remains in the basket and doesn't fall through the hardware cloth. And then also we're looking at how cloudy is the water. And you can certainly do this test in a way that takes a quantification by recording the percentage of the soil that stays in the basket after a minute compared to falls down to the bottom. And for the water murkiness, we're actually looking at different field turbidity tests that are used by water evaluators, like folks who do watershed river analysis to find a good quantification for this. But if you're just a farmer, gardener, kind of wanting to understand what's happening in your soil, a good way to do it is just to do this, to compare an undisturbed part of your soil with a nearby disturbed part of the soil. So here you can see that there's really not a whole lot of difference between these two. So the field edge sample looks like it's maybe shed a tiny bit less of its mass down to the bottom, and I'm seeing maybe a tiny bit clearer, maybe a little bit more murkiness in the infield sample. But my guess is that because Steve has been using these really great tillage reduction methods, and he's got a really good cover crop in place and lots of soil cover, we have a good strong amount of fungal and bacterial glues in the soil holding the particles together. So we're not really seeing a huge difference between these two samples, which is really a really nice indicator of health.